Yeah. Very good morning, friends. Folks at that outside, let me welcome each and every one of you for the 5th webinar on Module 2, Paper 4, Information Technology and Systems Audit. This is an exam-oriented webinar for the CS Professional Program, and we are in lesson number 6, Programming and Overview today. I'll say this is an important, very important chapter, for the reason this chapter is an alag chapter, very different. Why? Questions are not theoretical questions as you think where I will write in English form. This particular chapter, almost all examination except one exam paper where they have not asked even a single question in this particular chapter. Almost all the examination they have asked questions from this chapter, including a flowchart. So today I will be demonstrating how to diagrammatically present a flowchart in your answer paper. So today, apart from the lecture, regular lecture, we'll also have a demo session, a demonstration session. Few flowcharting techniques we will understand. And I want you to have a pencil, a notebook next to you. So parallelly, you have to actually draw. As and when I draw on the screen, you should also be able to draw it parallelly and then appreciate the concept of flowchart. And flowchart is a very fundamental programming concept. And not only with respect to programming, but also with respect to various process, flowcharting is an important tool. So we'll try to appreciate all those techniques today. So with this brief, let me take you into the study material. Your study material, chapter number 6, programming. If you look at this, what are all the concepts and stages of programming? The approaches for program development, algorithm, flowcharting concepts, and various levels of languages, high-level languages, machine languages. So one by one, let me unravel it. First, we'll understand what is meant by programming. I repeat, what is meant by programming. So today's date is 25th July, Saturday. We are on programming chapter. First point, what we will understand is, what do you mean by program? And this is connected with the 3 terms: algorithm, flowchart, and programming. So all this I will make this clear before I take you into some of the important concepts inside program. So up to this database we did yesterday. So now chapter number 6. So let us go inside this. Yeah. Yeah. So what is program? So in your study material, your page number 126. In page number 126, there is a paragraph called what is programming. So please pay your attention here. And I want everybody's attention to this one particular line. That's all, only this. So please be very clear. We will say, kuch program hai tomorrow, so I am already very busy. So what do you mean by program? And this word we'll be using in our daily routine usage itself. So what's the program? So for example, you want to go on a picnic. So you say, what's the program in that picnic? So travel, what is the travel plan or travel program? So we use this term quite often. Now, has it any meaning to computer programming, systems programming, that word and this? Yes, the meaning alone we'll take. But that is a generic term. Programming means set of instructions. Very simple. So I repeat that word once again. Programming means set of instructions. Now, let me take you to the next one. When you say set of instructions, for completing some specific task, this is important. So in a computerized environment, there will be a beginning, there will be an end. So those instructions has to actually complete the task. So then it is a program. So if it is not completing a task, it is not a program at all. So that means it is unfinished agenda. It is unfinished. The program has to be completed. So a set of instruction alone is not the key here. Set of instruction for completing result-oriented, task result-oriented set of instructions. So I will give 3 points. One is set of instruction. It should be task-oriented and the task should be completed. So what is the task? For that you have an instruction and it should be completed. Sometimes a task will be there, you find, instruction will be there. Will that instruction will lead you to the result? So that is where, so it should be complete. So it is not only you start a task and in Hindi mein bolenge khojna, so meaning in search of, okay. So set of instructions for completing some specific task. So that's called a program. Very good. Now, I will take you to how this set of instructions will be given. Computers will understand only one language. So the moment you want to give instructions to the machine, can I speak in human language? Can I speak in English language? Can I speak in Bengali? Can I speak in Kashmiri, Punjabi, Marathi, Kannada, Malayalam, or Hindi? None of the language it will understand. So those are all human languages. Okay, sign languages, nothing. That also it won't understand. So then, what is called as languages? What are the hierarchy of languages? And you have to give instructions in that language. Okay, you have to give instructions in that language. So let us let me take you to that particular part. Okay. And in the language, all these 5 will be dealt with. So the moment you say set of instructions for a task which should be completed, okay. Now, all these 5 will be forming part of that set of instructions. And this is an exam question. So please look here, guys. So I'll come to all these diagrams. Algorithm, advantage, major characteristics of algorithm, machine language. I think somewhere I missed it. Procedural programming, event-driven programming, algorithm. These are all questions. Okay. I think there's one more question is there. What are the major consideration and steps also advantages? Characteristic is a very popular question. Okay. Good. Check. Now, one by one, let me take you. So please look here. These are the 5 steps in programming process. Now, when you have to give instructions, you have to analyze the problem, design the solution, code the solution, test the solution, and document the solution. Now, what do you mean by this? We are going to do this with respect to some of the questions, and especially drawing a flowchart. So, for example, I'll give you a simple exercise. Okay, it's a morning time, and tomorrow we don't have a class. Tomorrow is actually 26th. So 26th is chutti hai. Okay. Now tomorrow morning, as usual, you get up early in the morning, and Maji, your mummy is asking you to buy sabji, vegetables. Go and buy vegetables for Sunday. This is the task. This is the task. So what is the problem now? Analyze the problem. It is Sunday. You don't have sabji in home. So you have to go and buy sabji, and you have to give it so that the food will be prepared. So if food has to be prepared, you need sabji. So sabji is not there. So inventory is not there. So that is the problem. Designing the solution. So then you have to think, okay, where sabji will be available. So how much sabji I have to buy? What is the quantum I have to buy? Should I have to go with my 2 hands so that I will bring it in my hands, or I have to take a bag? So that is a designing a solution. How will I go? By walk? How far it is? When you should come back? So how many planning is going on? See here. So designing the solution. Coding the solution. Coding means listing the instruction. So design is the thinking level. Design is at the, what do you call it, as a conceptual level. And coding is actually writing. It is putting in paper. So generally, okay, how many sabjis you want? Sometimes, if the family is very big, and if it is 1 or 2 items, you will remember. That itself is coding. But if the items are 10 items, 20 items, will you remember it? So what will you do? You will take a notebook. Wait, Maji, wait, I will note it down. Okay, so 1 kilo dhania. So number 2, okay. So Baji, how much? 3 bundle Baji. Okay, number 3. So what is the next item? So you need a sabji like brinjal, like aloo. Aloo is 2 kilos. So like that, you list out, and that is called coding. You list it out. So coding is actually writing. And when you write it, why you write it, I will tell you, because that particular part is very important, and I will actually zoom that particular part into 2-3 parts. Okay. The coding, first step is called algorithm, second step is called flowchart, third step is called programming. I repeat now, this coding alone will be 3. One is called algorithm, second is programming, third is, one is algorithm, second is flowchart, third is programming. The coding alone, I will blow into 3. Okay. Then the 4th one is testing. Okay, so you bring the sabji, like you bring a lady's finger. Okay, so your Maji takes one lady's finger, corner, she just breaks it. It doesn't break properly. Kya hai, this is old. Take it, go and return it, and then bring it properly. So customer has to be satisfied. The result has to come. So sometimes you will tell your sabji wala, see, if my Maji rejects, I will again come back, and you have to give me alternative, or properly you have to give. So maybe if you go to a mandi, or you go to a provision store. There normally you will have that lene dene, that give and take. You will be very comfortable with that. So that is testing the solution. Maybe 90% or 100% if the testing is done, or maybe at the conceptual level, algorithm level, at the flowchart level itself, it is proper. Coding also will be proper, and testing will give the perfect result. And we are going to do that. I'm going to experiment it with some more examples. Documenting. This is actually important in entire. See, after you deliver that program to your customer will run that program and he will have some problem. He will say, see, I type 40, it is coming 400. Or I type 400, it is coming 40. So where is the problem? How will you diagnose it? How will you rectify it? So diagnosis of the problem and rectification of the problem can be done only if you document it. Right from analyzing the problem, designing the solution, coding, testing. In test data, what are the data you have given? Input, what was the output you have got? But your customer will give a data called 400 and he gets 40. In testing, you would not have tested for 400. So that means problem is there. So then what is the coding? What if 400 is given, how it will do the processing? You have to go step by step and then understand how the process happens. So that is why this is very important, and please remember this, and every now and then I will be referring to this. Okay, good. So now next I am taking you to this is page number 126. I am taking you to page number 138, which is the various programming language, and especially machine language, assembly language, and high level language. Like so what is programming languages? So the third step. So what is your first step? Your first step is actually analyzing the problem. Second step is actually designing the solution, and designing the solution is at concept level. So design thinking, so at the thinking level. The third step is what is called coding, and that is what we call it as languages. So when you do the coding, that instructions, so programming language, programming is a set of instruction, it is a code. That code should be understandable by the machines. So this is the hierarchy. I repeat guys, this is the hierarchy. Please look here. So in olden days, when first generation computers was there, we used an instruction called machine language. We used an instruction called machine language. Now, can you understand anything from the 0 and 1? But actually, you need to understand 0 1 language, because machine understands only 0 1. So you will give instruction in 0 1. Machine will also give answer in 0 1. So can anybody else will understand it? That is the minus point with machine language. But the plus point is you are speaking in the machine's language itself. But can everybody do the coding? Can everybody be a programmer? Everybody have to actually understand the machine language. Because, for example, 0 means what, 1 means what, 1 0 means what. Because each and every, for example, numeric, there will be a value for it. For example, if you want to say 1, it is 0 means 0, 1 means 1, 2 means 1 0, because it is binary and it will be multiple to the power of 2. So 2 power 1 into 1 will be 2. If it is 4, 1 0 0. If it is 5, 1 0 1. If it is 6, 1 1 0. If it is 7, 1 1 1. If it is 8, 1 0 0. If it is 9, 1 0 0 1. If it is 10, 1 0 1 0. If it is 11, 1 0 1 1. This is machine language. So I will not tell 10 as 10. I will say 10 means 1 0 1 0 means 10. So how to add 10 plus 11? 10 means 1010 plus 11 means 1011. And plus you cannot give plus as plus. You have to give plus also one binary language for it. So 1010 for plus again you have to give a binary language plus 1011. That is called 11. Then answer will come in 21. 21 will come in again, it is 16 plus 4 plus 1. So actually 10101. So 10101 is 21. This is called machine language. Now, unless and otherwise you understand machine language, you can't work in that. Now, please look here. So, what is machine language? Giving coding and giving instructions, coding the language in machine language. So, that is in binary language. So, machine language is a native language. Native language, machine can understand. Even today, machine understands only machine language. But are we giving instructions in machine language? No, we are giving instructions in high level language. We are giving instructions in high level language. Please look here. What is high level language? And your study material, we have 103 participants online. We have in page number 138. Okay, this diagram is there. So hardware will understand only machine language, assembly language, high level language. So high level language to assembly language to machine language, and hardware will only understand zeros and one. And what are those high level languages? So look at the top one. The high level languages are high level languages. On top of it, it is not that. High level languages means. So in those days, it was Fortran, C, Pascal, etc., etc. Now you can say Python, Java. So all these are high level languages. Or you can even say fifth generation. In high level languages, again, you have various generation. First generation, second generation. These are all first generation languages. Machine language, assembly language, second generation language. High level languages, it will be from third generation language, third, fourth, fifth generation and all. We are now in fifth generation, where very advanced object oriented languages. So all those stuff we are going to understand now. Okay. So machine language we have understood. So it is only ones and zeros to produce commands. So input also 10, output also 10. Simple. That's machine language. But those are first generation hardwares, first generation languages. So first generation hardware, first generation software. First generation hardware will only understand 0 and 1. First generation software also will speak only zeros and ones. Now mature to the next generation. So the speed also increased slowly. And instead of using a machine language, we used assembly language. Now what is assembly language? We will not type in zeros and one. We will actually code in our English language with some syntax. Now I am going to introduce a term called syntax. Because the moment language is there, forget about machine, assembly level, high level. You take a language like Hindi, you take a language like Kashmiri, you take a language like Arabic, Tamil, Malayalam, Marathi, Bengali, whichever language it is, English. Language means alphabets will be there. Language means words will be there. Language means, I repeat, language means grammar will be there. Very important. Grammar will be there. So, grammar is for a human language. Syntax is for a machine languages. Okay. For machine language also you will have syntax. Assembly language also syntax. High level language also syntax. Now what is syntax? Syntax is the grammar of usage of the various levels of languages in coding. So assembly level language is a set of codes that can run directly on a computer's processes. Even machine language also will run directly understood by the computer central processing unit. Please understand this. Because CPU will only understand 0, 1 and you are giving 0, 1. So directly CPU will appreciate your instructions. But here when you give an assembly language, processor will not understand. So processor and between you, there should be an assembler, and that assembler will convert your assembly language to machine language, and again machine language output will convert back to assembly language, so you can understand. So one step advanced, and many people they came inside programming. Okay, from machine language. So, Babre, I need not even remember 0 and 1. Okay. Now, please look here. So, this is your assembly language. So, somewhat English and number. Only thing is, what is BEQ, what is INCR, increase, MULM, multiply. So, all this stuff was, so I need not use 0, 1, but I'll use English. But it was like an acronym, it was like, okay, so like a word. So, to some extent, it was comfortable and people loved it. People liked it to actually become a programmer. So, that is the first stage in bringing programmers into it. Then the third stage is high level language. That is, we can call this as third generation. And from this, everything started. Now, here is what you need to actually break your parts into. I said the coding part. I said number 1, algorithm. Number 2, flowchart. Number 3 is programming. And the rest called coding. So now after this, I'll go to algorithm. So high level language are user friendly languages. So C++, C, Visual Basic, Pascal, Python, so Java. So many languages are now there, which are similar to English with the vocabulary of words and symbols. So therefore, only thing is normal English language, you will use a grammar. Now what we have been conversing now, you are able to understand my English. But high level language will not use the normal English grammar. It will use if A is A, if open bracket A greater than symbol B, comma, okay, then A into B, comma, B into A, or B divided by A. So close the bracket. Now this you have to actually understand, because this is the way you have to give instructions. So high level languages are user friendly languages which are similar to English. Please look at similar to English, but not the English grammar. Because that is a syntax you have to use for that respective high level language, which is vocabulary of words and symbols. So predominantly our usage English will be there, but the syntax will be different. So that syntax is what you have to master to become a programmer. Okay. These are easier to learn and requires less time to write and much faster. So now please look here. So assembly language. So high level programming language. So now when you have the assembly language or high level language, how it will give instruction to the CPU. Remember guys, even today CPU only understands machine language. I repeat, CPU only understands machine language. That's all. Okay. Even today, it only understands machine language. So then how it will convert to machine language? Through interpreter, compiler, assembler. So this is an exam question. Please look here. So what is meant by machine language and high level language? You know what is machine language? The instruction will be given in zeros and ones. Processing will be done in 0 and 1. Output will be in 0 and 1. So you have to be very thorough in the machine language. High level language is English type language. English like language. So from third generation languages, it is high level languages. Okay. Now what is an assembler? Okay. And very popular questions are this assembler, compiler and all those stuff. And then we'll go to the flowchart and all, and algorithm. So after this, we'll go for flowchart, algorithm, all those stuff will go, and then we'll draw various flowcharts also. Okay. So please pay attention now. So now what is an assembler, compiler and interpreter? Assembler is for the assembly language. Compiler is for the high level languages. Okay. And what is interpreter? Interpreter is actually a translator. So I'll come for interpreter a little later. So generally assembler is in between assembly language. You have just now saw, I showed you how assembly language will look like. So you will key in assembly language, but the CPU will only understand machine language. So then in between assembly language and CPU, there should be somebody who will actually receive the assembly language, convert to machine language. CPU will give back the answer in machine language. I would again convert back to assembly language. So I am actually a translator, an interpreter. I am an assembler. So an assembler is a computer program, okay, computer program, which is used to translate the program written in assembly language into machine language and vice versa. So that human beings will understand, okay, you type some instruction, enter process, it will go process and it will give the answer in assembly language. So you have to understand, you have to be good in assembly language. So now the translated program is called object program. The assembler checks each instruction for its correctness and generate diagnostic messages. Now this sentence all of you must understand. Sometimes if you give a wrong instruction, so for example, at 8:30 a.m. if you do the programming without having morning tiffin, what you will type? Sometimes you will type 2 idli, 1 vada, enter. 2D, TWO, IDLI, TWO space, IDLI space, ONE space, VADA, vada, enter. You do the programming like that. Then will it give 2 idli, 1 vada and other chutney and sambar also, it will give South Indian flavor? No, it will say wrong command or not understand. It will say a wrong command or syntax error. Just one word it will say, syntax error. Because the language in which it understands, you have to give. Okay, so that is what they say. Human beings are also like that. So you have to understand the human being, the other side. If you speak in your language, the other side either he will not understand, he or she will not understand. Second, the he or she will get annoyed. And third, what will happen? The relationship will be weakened and it will be broken. So these are the things we should learn even in our life also. So that the assembler, so the way you speak, it should reach the other side. So if you reach the other side, you have to understand the syntax of that person. So okay, in which way if you tell, it will actually reach. And especially today's kids are very smart, especially 2000 plus kids. Those who are born above after 2000, you go and sit with such kid and speak. See, your mother may not agree, your father may not agree. Wait, I know how to make my mother agree or my father agree. So that kid, that boy or girl, will speak in such a way that the father or mother will understand. Oh, okay, he's communicating in that language. So today's kids are smart kids. So they are basically they know how to code it better without any diagnostic error. Without any diagnostic error, they will actually command. They will actually speak. Okay, they communicate. So that is very important. So when you will actually be a very good programmer, you should understand the syntax well. You should understand the other side well. Then syntax error will never come. Okay. So various steps of assembling are, this is the steps. So first give the input, use the assembler will compute and execute the program. Okay, execute. This is where there will be a term called loader and linker. I'll explain that loader and linker also. And very important guys, because after compiler, I'm taking you to the algorithm and flowchart, because that's very important. That's the question that actually asked in examination, and sometimes it is an 8-mark question also. 4 marks, 8 marks. So please be careful. Please look at this exam question. I'll now show you. See, they already asked 8 marks. So algorithm, assembler, okay. Flowchart, 4 marks. Now please look at question December 17, 8 marks. Flowchart alone. So therefore we have to be very careful. Here 4 marks. So December 18, 8 marks in flowchart. And June 19 is actually 4 marks plus I think it's 8 marks. So 4 plus 8, 12 marks is June 19. Okay, and December 19 again 8 marks. I'm sorry, only 4 marks. So it has been happening like this quite all the past. And since December 19, there is no flowchart they have asked. I am 100% certain that in December 2020 examination, there will be a flowchart question. Okay, so please, and which flowchart question, I don't know, but in your study material, there are only 8 flowcharts. So I'll try to draw as many flowcharts today, but understand the theme behind. And please use your pencil, pen, and be ready. I'm going to draw flowcharts after this particular question. So let's understand first the compiler. And as I told you, compiler is for a high-level language. So a compiler is a program that translates a program written in high-level language to executable. Please look at this, executable machine language. So machine language is zeros and ones. So a compiler, so high-level language is a programming package. You do the program, you give the instructions, enter, execute means you will get the answer. Answer you will see on the screen, but behind the instruction is converted, compiled, and then given to the CPU for execution, and after execution it gets the answer and it shows that in your language it shows on the screen. So all this is done at the back office. So here these are the steps the compiler will do. Translate the high-level language source program to machine code, trace variables, include linkages, allocate memory, generate error messages if it is there. Now please look at this diagram. This is the source program. Okay, so that is your high level program. So you can either substitute this with assembler or compiler. Okay, assembler or compiler. So you just put this as compiler here. The program will be converted to an object program. So this is called the linker. So there is a linker is also one part of the assembler or part of the compiler. And that linker will convert to an executable code. What is called executable code? That is what this object program is what will assembler, linker, loader. Loader is it will send the machine language to the CPU, get the answer from the CPU, and then again load it to the linker. And linker will actually ask what you call it, assemble it back. Okay, it will actually reconvert it from the machine language to the respective object program, and the assembler will actually give the instructions, the answer back in the human language to the screen. So this arrow mark will go like this. Again, the arrow mark has to come back. So there is one more backward arrow mark is also there. From the after the processing, again it will come to the loader. The answer will be in machine language. A linker will convert that to the answer in an object oriented language. And then the compiler will show the answer on the screen in the human language or the language in which we understand. So this is called the loader and linker, and this is used here to include linkages for subroutines. What do you mean by the linkages for subroutines? What do you mean by routine? Routine is the compiler has to convert to the object programs or object instructions that it has to break into machine instruction. Machine instruction will be loaded in the CPU, and CPU will give the processed data. Again, it has to convert to the object language, and then compiler will show on the screen. So all this will happen within fraction of a second. So that is the beauty of the compiler. Okay, so that's assembler and compiler. An interpreter is actually a basic purpose of interpreter the same as that of the compiler. Okay, but there is a slight difference. So in compiler, the program is translated completely and directly executable version is generated. Now, remember this high-level language, I mentioned it that third generation language is also high-level language, fourth generation language is also high-level language, fifth generation language is also high-level language. In third generation, we had languages like basic programming, beginners all-purpose symbolic instruction code. This is called the expansion for basic programming. Basic, COBOL, Pascal, all these are third generation languages. For that, there will be an interpreter. They will not have compiler. They will not have a compiler, they will have interpreter. An interpreter, what it will do is, the entire, for example, you are given 20 line instruction, entire 20 line instruction, it will actually interpret. And even if there is one error in, for example, there are 30 errors in 20 lines, interpreter will say error. Okay, go and again rectify. The 30 error will become 20 error. Again it will show error. Okay, go and again rectify. 20 error will become say 5 error. Again you interpret, again you actually interpret it, it will show. It is not actually executing. It will not send it to the machine, it will not convert to machine language, it will first do the interpreting. What do you mean by interpret? Whether you are given the instruction properly as per syntax. That is called interpret. In compiler, the program is translated completely and directly executable version is generated, where in compiler. But interpreter will translate each and every instruction, executes it, and then the instruction is translated, and this goes on until the end of the program. So line by line, it will actually interpret. So compiler, the entire instruction, it will actually execute. But interpreter, line by line, it will. So for example, in interpreter, there are 20 lines. First line, it will do the interpretation. Very good. Second line, third line, fourth line, it will do the interpretation. It will say error, syntax error. You have to find out where the error is. It will say line number 4. Just because in line number 4 error is there and you have rectified it, does it mean 5th, 6th, 7th, 8th up to 20th line it is error free? No. Again, you have to do the what you call as compilation using the interpreter. The first 4 lines it will through, again 5th line it will show error. So again, after rectifying, again if you do the compilation, it will do the interpretation for every line, and 8th line it will again show there is an error. So until the entire instruction is error free, it will not convert into machine language. So that is the interpreter mechanism. Okay, so that's the only difference between compiler and interpreter. Both are in 3rd generation language. Both are in 3rd generation language. Okay, good. So that's the speciality about it. Now please come to algorithm and flowchart. Very important. Okay. Now what is an algorithm? I'll just make this simple. If you need to, I will make this point very, very clear to even all of you guys. All of you are company secretary, professional program students. Our objective is to clear this professional program with flying colors. Okay. Now what we should do? What is the algorithm? Algorithm is, you have a notebook, everyday diary, take the diary and write to do instructions every day. What you should do today. And when you will write the to do instructions, you must have a plan for your entire next 3 months or 6 months. You are in which month now? You are in July. Your examinations is only in December. So August, September, October, November, 4 months. Make a plan for 4 months. So 3 months you will study. 4th month you will do the revision. 5th month is second revision or model exams, test and all. You put it, and how you will do the preparation. So all those stuff you have to make a list. And when you open the today's diary, yesterday night itself, before going to bed, you have to write to do instruction in your list. So in your diary you have to do. So today morning when you take it, okay, I have to do this 5 task today. Very important. So this is what I'm going to take as a cue. And machines are very systematic. I repeat, machines are very systematic. Only human beings are not systematic. And when human beings are systematic, success is definite. When human beings are systematic, success is definite, because you go by a program, you go by a process, and that process is task oriented, result oriented, task and result oriented. So result is definite. So program your timetable, go put that into small tasks, and the task you actually execute it every day, and you monitor the feedbacks. So from this, I'm going to understand one message, one lesson. And what is that lesson? And that lesson is here, page number 129. What is page number 129? Please look here, guys. And this is page 129. Yes. This is that lesson. An algorithm is a step-by-step procedure. Please look at this. Step-by-step procedure, result-oriented step-by-step procedure. I want result. So, focus on result and then arrive at the steps. List the steps. If that is the result I want. For example, all of you know what is quadratic equation is. Ax square plus bx plus c is equal to 0. This is quadratic equation. How to get the roots of quadratic equation? Step 1. Find d. D is called determinant and d is equal to b squared minus 4ac. Step 2. If d is equal to 0, what will be the roots? Roots are equal. Step 3. If d is lesser than 0, roots are imaginary. Step 4. If d is greater than 0, roots are real and distinct. Step 5. How to find the roots? The root is equal to alpha and beta or x1 and comma x2. So that is equal to, okay, so minus b plus or minus root of b squared minus 4ac whole divided by 2a. One root is minus b plus root of b squared minus 4ac by 2a. Another root is minus b minus root of b squared minus 4ac by 2a. All of you have done this. All of you have done this. Maybe in your 7th standard, 8th standard, 6th standard, you would have done this. Solving a quadratic equation. And any quadratic equation, 5x square plus 3x plus 8 is equal to 0. You follow the steps, you are going to get the answer. Okay? An algorithm, that is a mathematical algorithm for solving a quadratic equation. Similarly, can you solve a cubic equation? We'll have 3 roots. Here it is 5 steps. So cubic equation will have 8 steps. That's all. That is a cubic equation. So, like that for every, for example, to the power 3, to the power 4. So you have a solution, mathematical steps are there. So an algorithm is a step-by-step instruction to solve a given problem. So life also it is like that. In life, if we have written the algorithm very clearly, okay, I am going to borrow money. How much money I am going to borrow? 10 lakhs. Now fill up the form, get the money, borrow, and then swaha. How will you repay? So when you are taking a decision to borrow money, you must have the entire lifetime of that, what do you say, the loan amount, the money where you are going to invest, what is your return, how you are going to repay, and you have to monitor it very closely. And until that loan is completed, the instruction, the step-by-step instruction has to be followed. Has to be followed. Then only the loan becomes 0. Otherwise, the loan will be mounting linearly and it will be a burden on your head because you are not following algorithm. You are not following step-by-step instructions. You have deviated. So, we say financial mismanagement or we say financial indiscipline. One word we close it because algorithm is not followed. What is algorithm? You open a bracket and also you close the bracket. So that is algorithm. No, you only open the bracket, you never close the bracket, then there is it. So an algorithm is a step-by-step instruction to solve a given problem. Now in which language you will write algorithm? In machine language? In assembly language? In high-level language? In Marathi you can write. In Bengali you can write. In Hindi you can write. In Malayalam you can write. In Kannada you can write. In Tamil you can write. In Hindi you can write. In English also you can write. Algorithm is not for machines. Algorithm is for human beings. Before I give instructions in high-level language to the computer for interpreter or for compiler to do that execution, I myself as a human being must ensure whether that instruction is proper. That is why algorithm is must. Any software Before the software is developed, algorithm must be there. So when you actually do the systems audit, especially with respect to system development life cycle, you have been given a system audit to do the audit of a system development done. You want to do the audit. First question you should ask, have you created algorithm? Show me the algorithm, let me see. If there is no algorithm, then we have a very interesting sentence in English. If you fail to plan, you are planning to fail. There is no plan at all. Then definitely your program will be a disaster. Disaster. So an algorithm is must. Second step to algorithm, you have to convert that to programming language. Now before you convert that to programming language, I told you can write in English, you can write in Bengali, you can write in Hindi. Now I'm engaging you write the algorithm in Hindi, but a South Indian Karnataka from Hubli, I am engaging one programmer. He says, sir, I don't know Hindi. Okay, so what to do? The algorithm is in Hindi. You should know Hindi. No, sir, I don't know Hindi. So what to do? That algorithm will be converted to a diagram. Diagram is a global language. Japanese guys will understand. Korean will understand. Canadian will understand. American will understand. Chinese also will understand. I will not use China now. So everybody will understand. So what is algorithm? Step-by-step instruction. In which language you will write? Any language. Because you have to first get yourself convinced. What is flowchart? It is a diagrammatic representation. So what is algorithm? Please look here. A set of rules to obtain the expected output from the given input. What is your input? Rules, output. Write it in English, write it in Tamil, write it in Bengali, write it in Gujarati, okay, write it in Oriya. Agreed. In whichever language you like, you write it. That is algorithm. Ultimately, algorithm must be clear, understandable. Can you understand? Can you get the solution? That is the objective. For input, you will get the output. Okay. So, Bhasha is not what do you say, an impediment. Bhasha will actually enhance your ideas. Okay. And especially in your Matru Bhasha, mother language, if you actually write algorithm, the best. So now I am taking you to flowchart. And these are all some of the examples of algorithm. Please look here. Step 1, step 2, step 3, step 4. This is what I said about quadratic equation. Step 1, ax square plus bx plus c equal to 0 is the quadratic equation. What is step 1? Find d. D means determinant, which is equal to b square minus 4 into a into c. Step 2, if b square minus 4ac is lesser than 0, is equal to 0, is greater than 0, what it is? Then next, find roots under. That is steps. That is a step by step instruction, which is result oriented. So here it is an algorithm to find addition, subtraction, multiplication, division of two numbers. So these are all only to give you a idea about flowcharts. This may not be asked in examination, but in examination, the questions about algorithm is this. What are the major characters of algorithm? Okay, 7 characters. Okay, what are the 7 characters? Page number 130. These are the 7 characters. I already mentioned all this. So, number 1, algorithm must have a beginning and an end. End. So, I gave the algorithm for finding the roots of quadratic equation. Okay, b squared minus 4ac equal to 0. And then roots out alpha comma beta if it is roots. Minus b plus or minus root of b squared minus 4ac the whole divided by 2a. This is roots. So, the algorithm must have a beginning, b squared minus 4ac, find, and then end. End is what? Roots. The non-ambiguity requirement for each step of an algorithm cannot be compromised. What is non-ambiguity? I don't know, after this step, I don't know what to do. For example, that is why mathematics is a very beautiful subject, because every mathematics you actually have a steps and you arrive at a solution. So all mathematical, solved mathematical questions is an algorithm. So there is no non-ambiguity. And moment you don't solve the question, that means you have not solved at all. You will not get that feel of answering a mathematical question. Now, third is the third point. The range of input for which an algorithm was has to be specified carefully. What is range? Sometimes, for example, b squared minus 4ac. b squared minus 4ac, you will have three answers. It may be equal to 0. It may be lesser than 0. It may be greater than 0. Can it be any other number? Number means it can be negative, it can be positive, it can be 0. So range of inputs for an algorithm, or sometimes it may not work for below 0. Negative number, it may not work. For example, costing. All of you are company secretary, you have a subject called cost accounting. In cost accounting, you have designed one production linear programming problem, LPP. Linear programming problem, you have constructed it. When you solve that linear programming problem, x, y you have used and you have constructed an equation. X gets answer as 33. Y you get an answer as minus 12. In production, X and Y both are products. X means 33 units you produce. Y will you produce minus 12? It is not possible. So that is why the range can only be, sometimes the algorithm will very clearly say it can only start from here, end with here. So answer should be within that. It cannot be more than that. Sometimes a very big number also it is not possible. Very small number, negative number, it is not possible. So all those, what you say, non-negative integers and all, you have to give that as part of your algorithm. The same algorithm can be represented in several different ways. So remember guys, here I have to give you the definition of engineering. I repeat, I have to give the definition of engineering. Now we have come to 9 o'clock. After this, I'm taking you to flowchart. What is engineering means? Engineering is any complex calculation or any complex arithmetic, any complex work, you are making it simple. You are making it simple. That is engineering. A complex thing, if you make it much more complex, that is not engineering. That even I will do, you will do, everybody will do. I am not an engineer. So therefore, you are give me one complex calculation or a complex work, okay, a civil work or a mechanical work. I don't know civil, I don't know mechanical. So I will make it much more worse only. Is that engineering? No. Engineering is making a complex thing simple. Okay, as simple as possible. Can you make it much simple? Can you make it much simpler? That is where is engineering is. The same algorithm can be represented in several different ways. So I give one calculation to be done by two different persons. I don't make them interact. And they will give two different algorithms, but same answer. Which is the best algorithm? The simplest algorithm. The simplest algorithm is the best algorithm. One guy has written 28 lines. Another guy has written 8 lines. 28 line program, oh, he has complicatedly, he has given an algorithm. He has given a simple algorithm. For a complex situation, giving a simple algorithm is the most complex thing. Please understand. So that is the best algorithm. So several algorithms for solving the same problem may exist. That is why I said this. Okay. And it must terminate at a reasonable period of time. So good. So with this, I'm now taking you to flowchart. Now, what is flowchart? Diagrammatic representation of an algorithm. Algorithm only. But algorithm will be in language. Bengali, Gujarati, English, Hindi, okay, Arabic, okay. But what is flowchart? Flowchart will be in diagram. So anybody can understand. Japanese can understand, Korean can understand. So now, if I have to draw a diagram, I have to use symbol, and that symbol is this symbol. Good guys. This is start and end. And I will only use this 5 symbols. I'll only use this 5 symbols. Now I'm going to draw flowchart. Okay. Okay. So please be ready, guys. So what I will do, I will give the algorithm or I will explain the algorithm, or you can note down the algorithm, and that algorithm I will actually convert that to a flowchart. Okay, and I'm going to draw that flowchart in a board here. This is the board. Hope this board is visible to all of you. Yes, this is visible. That's good, guys. Yeah. So I think in this I'm going to draw this your flowchart. So this is my board now today. So with this board, I will draw a flowchart. So technology has given us, leveraged us a lot of things to actually use the tools online and then use it. So this is an online flowcharting tool, which I'm going to use to draw a diagram. But you have to draw whatever I'm going to draw here. You have to draw in your paper, but only in paper only you have to draw. No, for getting the marks. Okay, so this is your start and stop symbol. So every flowchart, the beginning symbol will be a oval and end also will be oval. And all the symbols I will connect only with an arrow mark. One-sided arrow mark. I will call it as a waterfall arrow mark. So from top till bottom. You should not draw a diagram. No. For me, Vastu is not correct from top to bottom. Only from left to right I will draw a diagram. No, you are wrong. People may not understand what a flowchart is. Flowchart means it should flow from top to bottom. It should flow like a waterfall. So just because no, I am a left-hander, I am a right-hander, my Vastu only works from left to right. So all those stuff and all will not work because this is a standard representation of it. I will say a standard diagrammatic representation of an algorithm. What is algorithm? Step-by-step instruction, result-oriented. So result-oriented step-by-step instruction, standard diagrammatic representation is flowchart. So symbol, oval, arrow mark, I am clear. This is actually called as a parallelogram. Parallelogram. So two parallel lines. So parallelogram. Generally, parallelogram is used for input and output. Input of data, output, that means printout. So input and output, always you will use this two symbols. In between, you do the processing, you do the instruction, you do the calculation. For calculation, you use a rectangle. And rectangle is process. Sometimes you have to make a decision, this side or that side, yes or no, left or right, male or female, greater than 10,000, less than 10,000. Then use a diamond, or maybe you can call this as a rhombus. Okay, it's a decision box. I'll only use these symbols, not more than that. Even though there are more symbols are there, please look here. Even though more symbols are there, like all these symbols are there. See, this is a rectangle. This is a rounded rectangle. Text is there. Ellipse is there. Square is there. Circle is there. Process is there. So different symbols are there. But I will not use all this stuff. I'll only use this 5 stuff, guys. Okay. So hope all of you are ready for flowcharting. Let me start with flowcharting now. Good. So let me finish the theory part on flowchart. This is a flowchart you have to draw for to read 2 numbers and print larger of the 2 numbers, 4 mark questions. I'll do this. What are the advantages of flowchart while solving a problem? Very simple, universal, easy to understand, and easy for programming. When I am a programmer, I need not see algorithm. I'll see the flowchart, and flowchart says start next to this. Directly I will do the programming. But algorithm, it only gives steps. Sometimes the steps, how it is connected, we may not know. So from step number 8, it will again go back to step number 2. So all those connect will not be visible, or clearly you can actually get the understanding in a algorithm. But in the algorithm, that English will be there. But diagrammatically, when you connect with the going up, down and all, you will have a clarity. So therefore, flowchart is much more visible. More anything that is visible, you actually get more clarity. So that is the advantage, and that is given to you in page number 133. Here also they are given. See all those stuff, the symbols they are given, but I'll only use a few symbols. So one is communication, effective analysis, proper documentation, and efficient coding, proper debugging. So whenever your program is wrong, you go back to the flowchart. Flowchart will give the proper instruction. So the flowchart will give a result-oriented diagram, but programming you would have done wrong. So when you look at the flowchart, oh yeah, I have, instead of linking it to the previous chain, I have linked it to the next chain. So the result is getting wrong. So therefore, flowchart will actually be very, very helpful for debugging. Debugging means error in a program can be rectified. So efficient program endurance. So all those can be done. Okay, good. So one thing I want to tell all of you guys, being a company secretary, being a professional, don't ever think that, oh, what is this stuff? This stuff is nothing to connect with my profession. But remember, there are many life lessons you will learn from this. And not only life lessons, when you work in, maybe you will be working in a software company, you will be working in a cloud company. Today, there are many cloud companies are there. And even your own practice, you may use, today everybody we use technology only. So therefore, you need to understand programming fundamentals, etc. You need not be a, what do you say, an ace programmer, but what programming is, how it is done, that you must be able to appreciate it. Okay, good. So now what are the other questions? So what are the major characteristics algorithm? Flowchart to find the sum of squares of first 15 odd numbers. So we'll do that also. I think I'll do one by one, step by step. So draw a flowchart to read two numbers and print larger of two numbers. I'm going to do this. So read two numbers. Okay, input two numbers. So I will say two numbers is A, B. And larger of two numbers, so greater or lesser than. So let me do that first. So yes. So I'll say start. So what is the question here, guys? Read two numbers. So I need input. So I'll have this. So input A comma B. So what is your question? Read two numbers. So input two numbers. Or even instead of saying input two numbers, you can even say read two numbers. Anyone you can use. And print larger of two numbers. So for example, A and B, say A is actually 7. You are saying input A is 7 and B is actually 10. B is actually 10. So then which is greater? 10 is greater. So B is greater. Then what to do? I need to actually compare. Now how do I compare? I will compare using which symbol? The diamond symbol. Okay, that is called decision. So decision box, diamond is here. So again, I will connect it. Maybe I have to. Maybe whatever it is, let it go. So is A greater than B? This is the question. Okay. Is A greater than B is the question. So now what I will do, for example, A is greater or B is greater, anyone. So that means two possibilities are there. So I'll again have a parallel. And I will have one more parallel. So is A greater than B? I will type a text. No. I'll type one more text here. Yes. So if A is greater than B, okay. So if A is greater than B, yes, sir. I'll say print A. If A is greater than B, no, I'll say print B. Okay. So now I'll again I have to close it. So how do I close it? maybe I have to, so this is, I will say end. So that's all, print is over, no? So end. So similarly here. That's all, over. So this is your flowchart for 4 marks. So draw a flowchart to read two numbers, A, B, you read it, and print larger of two numbers. So compare A, B, if A is greater, print A, that means 10 greater than 7, yes, print 10. 7 greater than 10, no, then print 10, because B is 10. So then come in, right? Okay, now let's move for the next one. One more, or 2 or 3 flowcharts I'll try to do, okay, maximum. So another flowchart, I'll take you this. Draw a flowchart to find the sum of the squares of first 15 odd numbers. Okay, so we have 116 participants. So hope you are drawing parallelly along with me. Okay, so draw a flowchart to find the sum of the squares of the first 15 odd numbers. Now I'll just share with you one more working so that you understand what that working is all about. So please appreciate that working. What do you mean by this particular question? So he says, I'm sorry. He says, find the sum of the squares of 15 odd numbers. Now, how do we find this? You need to actually understand the question. So please look here. The question says, sum of the squares of first 15 odd numbers. So this is the first odd number. The second odd number is on this plus 2. Please understand. Okay, so first 15 odd numbers. So this is your 15 odd numbers. Okay, so all of you are clear with this? So this is your 15 odd numbers, I'm sorry. So this is your 15 odd numbers. And the square of this. So what is your square of this? So this is your square. And what is the sum of this? You need the sum of this. So this is called algorithm. So 4495 is your answer. Your question says draw a flowchart to find the sum of the squares of first 15 odd numbers. This is 15 odd numbers. Okay, so how do you know that it is 15? The row number itself is there. So this is your, I will count each and every number. This is the 15th number. So first number is 1, second number is 3, third number is 5, fourth number is 7, fifth number is 9, sixth number is 11. And 15th number is 29, and 29 square you have to do and then add to it, and then the total is 4495. So this is my answer. Now how do I draw this as a flow chart? So let me show you that. Yeah. So please look here, guys. Hope it is visible to all of you. Good. So now what I will do, I'll have the steps here. What is the step 1? I'm writing the algorithm to all of you. So maybe I'll again go back to the same steps so that you will know what an algorithm is. This I'm writing an algorithm. Step 1. Okay. Let n is equal to 1. Okay. Step 1. N will be 1 and count will be 1 because this is n. This is the number called n. This is the count called c, and this is the sum. I'm adding it. Okay, to all of you. So maybe I'll reduce the. Hope it is visible to all of you. Good. So first step 1 is this. So now what is step 2? I will say n I have to increase because what I have done, 1 after 1 n becomes 3. So n becomes n plus 2. That means originally n was 1. 1 plus 2 becomes 3. So right hand side n is old n, left hand side n is new n. So this is old. This n is actually old n. So red color. This n will be green color. So this was your old n. So n is 1. So 1 plus 2 will become 3. Then again the n will become 3 now. Then 3 plus 2 will become 5. Okay, so that is step number 2. Step number 3, what I have to do, I have to square this. So n I will square this because already s is equal to 1. That also I will say. So s also will be 1. Because what is s? S is some 1. Now this 3 I have to square it and add it. So what I will do, s plus s is equal to old s plus the new n square. The n I have to multiply into one more n. So n into n I will add to the old s. So this is my old s. So again red color. This is your old s. And this becomes your new s. And new s will become again red color at the beginning. Then again you square it again. So you have to loop this. This is called looping. And in your study material, they have mentioned the algorithm and the flowchart. What are the 3 types of structuring in algorithm? Sequence. This is the sequence 1, 2, 3. Second is branching. Third is called loop. Sometimes you have to repeat the same process. So that is what I am going to. Step 3. Now what is step 4? And this step 1, 2, 3, 4, I will be drawing it as a diagram. So step 1, 2, 3, what is 4? 4 is actually, I have to, I already know what is yes. Now check whether, check is C is equal to, counting whether it is 15. If it is 15, exit. Check if C is equal to 15. So if yes, exit and print yes, because yes is the sum. If no, if step 4 is no, repeat step 2 onwards. This is your algorithm base. And whatever I have done this here as an arithmetic, I have given you in algorithm, that is in English. The same algorithm I can tell you in Tamil, I can tell you in Marathi, I can tell you in Hindi, I can tell you in Telugu, I can tell you in Punjabi, I can tell you in Korean, Canadian, whichever language you want, we can Spanish, Italian, you write. That is to be appreciated, understood by human beings. Now using this algorithm, I am going to, please note down this algorithm guys, everybody please note down step 1, 2, 3, 4, 5, note it down. Using this step, I am going to draw diagram. Okay. So now, what is the first step? Start. Every time you know this is start only is the first step. Okay. Then what is the next step? N is equal to 1, C equal to 1, S is equal to 1. This is called assignment. This is called assignment. Other is called input. So input you will use which model? You will actually use process is calculation. For process you are actually using a rectangle. For input you will use the parallelogram. Okay. So here N is equal to 1, C is equal to 1, S is equal to 1. So input N, C and S. If you are giving as input N, C and S, use this symbol. But sometimes you may need to give assignment, because when you are giving assigning, you can use the rectangle symbol itself. Okay, so I'm using an assignment symbol here. Please, this is called assignment. I'm giving values. Okay, so what are the values we are giving? Let n be 1. N is equal to 1. comma, C is equal to 1. C is called counting and S is equal to 1. S is actually the square of n, because 1 square is 1 only, and that I am assigning to S. S is a variable called a summation. Good. Now what is your step 2? N is equal to n plus 2. That is also computation. So therefore, that also I will use this. So n is equal to n plus 2. So that is n is equal to n. What is the next step? S is equal to S plus n square. That is also computation only. S is equal to S plus n into n. Good. So that is your S is equal to S plus n plus n. And what is your next step? Is check whether C is equal to 15. So how do you check with C is equal to 15? You will use a, what do you use? You will use a rectangle, I mean a diamond. Is C is equal to 15? If C is equal to 15, mean you have to exit. So what you will exit? You will say print yes, because that is your question. What is your question? Sum of the squares. Find the sum of the squares. So yes only you have to print, and the answer for that is 4495. Okay. So print yes. And after that end. Maybe after that end. That's it. So now if it is C is equal to 15 is not there, then you have to start again n plus 2. You have to go to this particular step. So what I will do now, I will actually connect everything. So next step, this is the next step. Another connect this. Another step, connect this. Another this, connect this. It actually gets connected automatically. Another one, or maybe, so this is end. Okay. Now another one, I have to go and connect it here. So what I will do, so I will, so if C is equal to 15, maybe I'll put a text here. If C equal to 15 is no, then again go and connect here, again n equal to n plus 2. If C equal to 15 is yes, then print output. That's all. Okay, come. So you have got how many marks? Guys, you have got 4 marks. Okay. So now very simple, let me take you to another question here. If basic salary is less than 30,000, then HRA is 10% of basic salary and DA is 75% of basic salary. Actually, these kind of questions are, you have to create the algorithm and draw the flowchart. And as far as questions like this, algorithm is already given, entire steps is given. You have to straight away you can draw the diagram. It's very simple, and 8 marks, just like that you can get it. So very quickly I will do. Okay, so December 2018 question, your December 2017 question, and your June 2019 question, all are what you call it as a simple question with only with respect to these are all called as decision making question. Decision making come computation question. Okay, so any one I will do quickly, so please pay attention. Either December 17 or December 18 or June 19, any one I will do. Okay, okay. So let me do, maybe I will do December 18. Okay, so hope all of you are comfortable so far. Okay, so there are 7,000 students in a university. Okay, Remember guys, there are 7,000 students in a university having 3 different disciplines. So medicine, engineering, arts. The discipline codes are given, MEA. Draw a flowchart to read the name of the student, discipline code of the student, and the file from the file, and print the total yearly revenue earned by the university and the number of students. So in each code, find the number of students and you have to accumulate it. Okay. So M is equal to first student. Then count it, you have to find out how many counts are there. Okay. So once the number is over, once you have finished it, counting it, then at the end you have to do a computation. The number of M students into 90,000 plus number of E students into 70,000 plus number of arts students into 30,000. That will be your total revenue. And how many students are there in each discipline? In medicine, M students. So output medicine equal to number of students M. In engineering students, number of students equal to E, because E is the number, A is the arts. So let me first list the algorithm, then we will go for, so I'm going to give the algorithm first guys. So I'll put the steps here. Okay, step 1. Okay, so let M is equal to 0. Okay, that is medicine. E is equal to 0. To start with, students will be 0 only. You have to check the student code, then you have to add it. Then arts is equal to 0. Okay, so that is then step 2. Then once you got the number of students, you have to multiply at the end. Okay, you have to multiply. Step 2, input student code. Okay, input student code. So step 3, if code is equal to M, then M is equal to M plus 1. Or if code is equal to E, then E equal to, then E is equal to E plus 1. Else, you have to say A is equal to, if they are neither medicine nor engineering, there should be arts only. A is equal to A plus 1. You are adding the student count. So step 4, this is an algorithm. Check. Okay. So this is student number 1. Input and maybe I'll say count. Count also I'll have it here. Okay. And count is equal to first student. First student input you are giving. Now step 4, check whether the count is equal to, how many students are there? There are actually 7,000 students. It is 7,000. If count is equal to 7,000, you have to exit and print. What you have to print, I will give it in step 5. Exit and print. Else, C is equal to C plus 1, next count, and then input the student code and include that. Step 2 and 3, you have to repeat it. Check, you have to repeat it. And what is step number 5? You have to find the total revenue. Total revenue, TR, is equal to, okay, the number of students, medical students into, okay, M into number of medical students into fees is 90,000. Okay, plus the number of engineering students into the fees is actually 70,000. Plus the number of art students into the fees is actually 30,000. Okay, and then print the total revenue and the number of medicine students. So M also you should print, engineering students also you should print, and art students. So the number of medicine students, number of engineering students, number of art students, and total revenue of the college. This is your algorithm. Simple. Now let's do the what do you say, the flowchart quickly. Good. Good guys, I think it is visible to all of you. I'll first start with the start symbol. So all of you have noted the steps. First step is let m is equal to 0, e equal to 0, a equal to 0, c equal to 1. So then that is called assignment. So I'm going to do the assignment. So let, okay, count is equal to first student and m is equal to 0 as of now. The engineering is equal to 0 as of now. Okay. And arts is equal to 0 as of now. So once you, maybe I don't need much bigger than this. This is sufficient. Okay, good. So now what is the next step? Input the student code. Sorry. Input the student code. So what is input then? Input is parallelogram. So input the student code. Okay, good. Now what is the student code? M or engineering or arts. So now I am going to use the rectangle. Very important rectangle. Very important. I mean, say diamond box. So if the student code, if the student code, or I'll say just code. Why is student code? All are student code. Input code. Code is equal to m. What to do? I'll put one more diagram. Code is equal to E. What to do? If code is equal to m, if it is yes, then I will say m is equal to m plus 1. If code is equal to E, if it is yes, E equal to E plus 1. Okay, the same yes, I will put for here also. Now, if it is no, it should be definitely, it is neither medicine nor engineering, then definitely he should be arts. So it should be A equal to A plus 1. I need not check once again. If there are three people, I'll only check whether are you medicine or are you engineering. If neither you are medicine nor you are engineering, you are a student of my college, definitely you should be an art student. Okay, because you have a code. So I need not check for the other one. So A is equal to A plus 1. Then I will check whether I have everything will now zero in on whether I have is the number of students, because what is it? Is the count is equal to C is equal to 7,000. The C is not 7,000. No. C is not 7,000. No means I will actually go to the next student. C equal to C plus 1. And then input the code again. So, and if it is C equal to 7,000, yes means I have to do the computation. What is the computation I will do? Total revenue is equal to, okay, M into 90,000 bracket plus your engineering into, what is the engineering fees? 70,000 plus arts into, What is the arts fees? 30,000. This is total revenue. So then what is printout? Printout is again your parallelogram. So what do you have to print? You have to print so print your number of students in medicine, number of students in engineering, number of students in arts, and the total revenue. That's all. Then end. Okay. So now let's connect all this. Now connect all this. Connect all this. Connect here. So if it is yes, yes. So if it is yes, connect here. So if it is no, you have to connect here. So maybe I'll put no here. Yes. So now if it is so I'll check here. If it is no, I will be connecting here. Then again I have to connect here. So I'll be connecting up to this point. Yes, sorry. So I'm sorry. So I have to connect to, I will do once it is no, add the student and then connect to the input code. So if it is yes and both are yes, then I have to, these three I have to connect to this particular point. I think from here. Yes. So after m is equal to m plus 1, e is equal to e plus 1, it will get connected here. This also will get connected. Yes. So, and then from here, it will be connected here. From here, it will be connected here. From here, it will be connected here. That's it. So this is your 8-mark question, guys. And how you are able to draw this? You are able to draw this only because of the algorithm. Simple. Okay. So guys, thank you very much. We are now at 9:40, but before I close, may I now request any questions from all of you? Anyhow, I'll share all this stuff to you through my blog. You can go to that blog and you can download it. So these stuffs and some of the questions and answers I have already given here. Okay, and maybe these diagrams also I will attach to that. Maybe from here I have to copy and paste it. That's it. Okay, and we have this algorithm. This algorithm is also very important. So this is the algorithm. This is the algorithm. Step-by-step instruction to arrive at a solution. Okay, and based on this algorithm only that flowchart is done. And based on the flowchart, programming will be done. Okay. So good guys, any questions? You're welcome. Apiksha, One more. Thank you, Titiksha, Apiksha, Anjali. Oh, flowchart also I will share. Okay. Anything else? Any questions? We have some in Q&A. Somebody has typed something. QCOM BTD. I have told you very clearly. Whenever you are using chat box, you have to put your name and location, and that shows professionalism. Okay. Madhuri from Kolkata. What is a program development life cycle? We'll look at that. I think, is it forming part of this, or I think there is a different separate topic, no, on the program development life cycle. Yeah, program development life cycle is here itself. Generally, PDLC, program development life cycle, is the time taken to develop the entire program, right from the designing stage, development stage, coding stage, testing stage, and till implementation stage. So that's called the PDLC. So Priyanka is asking, do we need to write the algorithm before drawing the flowchart? Sukanya Damal, Pune. Actually, it will be very simple to draw a flowchart if you write the algorithm. Okay. Vanita, North Mumbai, please repeat the step for last two questions. Little bit confused. You use this diagram and the I have given you the algorithm. Try to repeat it. Try to practice it. Okay. And you have been given 8 questions with answers in the study material. Try that also. It will be simple. Nikita from Hyderabad, if the flowchart can't be completed in one page, then how can I connect in the next page? Very simple. Use a connector. And connector is nothing but an arrow mark with a small circle. Arrow mark with a small circle, say alpha. And the next page start with a small circle alpha, start arrow mark. That is called a connector. Okay, that's called a connector symbol, and that connector symbol is a small circle. Okay. Where is it? Small circle. Small circle is not here. Maybe here small circle. Yes, circle is there. You can use that circle. Okay. Good. If you draw flowchart proper, get full mark. Yes, 8 full marks you will get. Poonam Bansal, if we have to input any number and also assign any number, then do we need to draw a rectangle along with the input diagram code? No, rectangle is sufficient. It is not input. Input means you have to use a parallelogram. Assignment means you have to use a rectangle. Okay. Then assignment you draw one rectangle. Input you draw a parallelogram. Lohit Karkeka from Udupi. Lohit from Udupi. If small mistake in flowchart, we will lose whole 8 marks. No. That is why you write the algorithm. You write the algorithm, none of you will make a mistake. You know, those days, even nowadays also, I should say, India is a very traditional country. Well, every day morning, the girls, women in home, they will actually sweep the doorway and they will sprinkle water and they will draw kolam. They will draw kolam. That is called rangoli. In Hindi, it is rangoli, and in South India, it is called kolam. You know, those who are very good in drawing kolam, I will say flowchart is nothing for them. Nothing. Actually, we have to go and learn from them. That too, column with is that pulli column, that what you call a dot column, not rangoli. Putting a lot of colors is not that difficult. Dot column, 9, 12, 18, 21, 24, dot. Start in one place, karu, again, and then join at the same place. That diagram, if you master it, flowchart is nothing. Nothing. Everyone can do. But we have forgotten that art. Sorry to say that. And girls, if you are very good in drawing columns, flowchart 8 marks is yours. And boys, you have to understand one thing. It is not that column only girls can draw. Even boys also can draw. And I have drawn column outside my home. That too pulli column. I will actually use a notebook, practice that pulli column. That called dot diagrams, dot rangolis. and then I will draw there. It's such a fun, such a learning, and there is a yogic exercise is also there because you have to bend and draw. Please try. New flowcharts question have to be drawn on new page. Yeah, definitely. Is it necessary to insert C as I have been drawing flowchart without C? C is actually a very good mechanism to actually start counting and then end with when you have to end that. So that actually give you a logic why you have to actually exit. So therefore C is a very good control. Okay. So good guys. Madhuri from Calcutta, again you are asking the same question. Flowchart symbols are important while using flowchart. Only 5 symbols that you have. 5 is enough for your entire examination purpose. 5 symbols is enough. Why you are bothered about other symbols? Pinky Kanojia from Ahmedabad. Okay, what is your question? Aishwarya Khanna, please explain programming methodologies. What is programming methodologies? It's here. Yeah, there are 2 kinds of programming methodology which will be asked in exam. One is called procedural programming, another is event-driven programming. Event-driven programming, in MS Excel, there is a visual basic programming is there, where you can actually do a macro. Macro is actually programming. In macro, how to enable a macro programming, you can use one shortcut key, Control ZF, and you can, until you press Control Z and F, that program will not be run. That is called event-driven programming. That event is called, you have to use the keyboard called Control ZF. That's called event driven. Sometimes time driven. Time is also, it can be time driven programming. But procedural programming is traditional programming. You would write the program, save it, and then use a compiler or an interpreter to run it and execute it. It's called procedural programming. That is also an exam question they have asked. Before making flowchart, is it necessary to tell what symbols we use? Means not necessary. Okay. So guys, thank you very much. My best wishes to each and every one of you. See you not tomorrow, day after tomorrow, morning 8 a.m. and have a great weekend. Celebrate your day and prepare well the 6 chapters. Almost 50%. I think more than 50% we have covered. Guys, more than 50%. 142 pages we have covered, guys. 142 pages we have covered out of 290 pages. So out of 290 pages, 142 is being covered. So almost 50% we have covered. So the balance 50%, next week I'm completing it. Thank you very much. Okay. See you guys.